Here we have a more challenging problem. Not only do we have a larger data set, but we're asked to do a hypothesis test on the correlation coefficient. So the first question to consider is, how are we going to get this data into R? Of course, we could build an object called X and type in all of that data one at a time, and then an object called Y and type in all of that data. But that would be a little bit time-consuming and frustrating, so here's another alternative. Because the data is available to us in this electronic format, we're reading it on the screen, we can copy that and put it in a spreadsheet. So, highlight the data and copy it. So to get this data into R, I need to save this data as a comma-separated variable file. So when I told it to save as, it gives me a chance to rename this file. Down here I need to make sure that I change it to a comma-separated variable file. Let me pull that. Here's my comma-separated variable file. I'm saving that. Those options will be fine. So if that file is saved, I need to go back and find R. Now this line of script has possibly two new commands in it. We're going to build an object called data. This could have any name that you wanted it to. We're going to use the read.comma-separated variable file command, which is going to expect to have a spreadsheet that is stored as a comma-separated variable file. And then inside of that, I'm going to use the file.choose command. This command, when it is run, it's going to allow me as the user to go and find the file that I want it to read and ask it to show what the data is. So now let's run this script. So there we are running the script. It gives me my chance to find the file. We put the file in Documents Demo. You had to pay attention to where that was. There's only the one file there, so I highlight it and open it. It reads that file, and then we ask it to print it out. Now look at what it printed out. It printed out what is called a data frame. So the first column in this is the X values, the second column is the Y values. Over here on the left it tells us what row we're in. So let me just come down in the R console and do some things here. Notice that when we look at the list of objects we've got there, we've got a bunch of them. But one of them is this data that we just built here. Okay? And if I look at data, let me print out data again so that you can see it. There's data, and there's the last few lines of data. If I look at data and look at the 33rd row, the second column, so there's the 33rd row and there's the second column, it tells me that the amount that's there is the 76.3. If I wanted to look at everything that's in the first column, I could look at data, no restriction on the row, but look at the first column. And so there's all the data that's in that first column. Notice if we pulled up here, the last item there was 67.7, 67.7. And of course, if I wanted to look, those are all the X values. If I wanted to look at all the Y values, I could look at no restriction on the rows, but the second column. Okay, so with that, we're going to go back to the script and build our X and Y from that information. I'm going to remove this data from the script and build my X and Y. So there we are, creating our X vector, which is the second column of that data, is the first column of that data frame, and the Y vector, which is the second column of that data frame. Notice that I get all the rows. So let's run this script and ask it to show us what that X and Y are. And there's our X and our Y value. And if you think about it, that's really, although we had to learn some new skills, we had to learn this function, the read comma-separated variable file, and we need to find this file choose. We had to copy the data into a spreadsheet and save it as a comma-separated variable file. But that's a lot quicker than having to type all of these in. So highlighting the core of xy and running it, that tells us what the correlation coefficient is. So let's turn our attention for a minute to what our hypothesis test is all about. We're considering all the different R values that we would get from bivariate samples and looking at the correlation that we get from each of those samples. If there is no correlation, then that R value is going to be 0. We already noted that we got a positive correlation. So let's ask the question, is the correlation significantly greater than 0? So the alternative hypothesis is that R is greater than 0. And the null hypothesis is that R is less than or equal to 0, but the null hypothesis is always listed as just equal to. So we'll be interested in finding the area of this blue area. That will be our p-value. We'll find that blue area by looking at the t-value of our point estimate. And as always, the t-value will be the point estimate, which is our R value, minus the R value from the null hypothesis divided by the standard deviation of the distribution of the R's. Now we'd like to find the p-value for this correlation coefficient. That means that we need to find a t, and they've given us the formula for finding that t. We'll talk about the theory of that in another video, but for right now we can build that content. Before we do, the one piece that I need to know is how long these vectors are. How much information is there. I can use a command in R to help me do that. The length command in R will tell how many things are in a particular vector. So let's just find the length of x. That, of course, is the same as the length of y. It's the number of bivariate data pieces we have. So now looking at the formula that we need here, we'll just build the t-value. So there we've executed the program that they said for that t-value. Okay, diagnosing the problem. Here we were using R for the correlation coefficient, but we hadn't said what R was up here. So let's define that as being R. Before we had just wanted to show what the correlation coefficient was, but we really need to save that value as R so that we can use it in the calculation down below here. So now here's the idea. The null hypothesis is that the correlation is 0. So we're looking at the alternative hypothesis that the correlation is greater than 0. So we need to find the p-value is going to be 1 minus the pt of the pt of that t amount. So that'll calculate our p-value. So let's run the last part of that script. That gives a p-value of an extremely low amount. This p-value should be 0. And there we are. There's the R that we calculated, the p-value, and the conclusions that we've made.